What's going on, guys? Let's do this problem right here. So we have the first question that's asking for the integral of tan x dx. Let's see how we can find this. So first of all, tan x can be written as, let's use a different color. Okay, tan x can be written as sin x over cos x, right? Sin x over cos x. Here we know that each of them are derivative of each other. Like sin is derivative of cos, cos is derivative of sin, and therefore we can do the u substitution. So let's pick up u. Usually we pick up the denominator as u. So denominator is cos x, and the derivative of cos x is going to be minus sin x dx. But here we have plus sin x dx on top, so we have to change it into plus. So I can change it by taking negative in front. Minus d is equal to sin x dx. Now I can write this one in terms of u. So let's write this one in terms of u. So for the sin x dx, I can plug this minus du, but let's take the minus into the front. Du right here, and instead of cos x, I plug the u. So it's 1 over u, right? 1 over u du. And 1 over u, if I integrate 1 over u, that's ln u. So here we are going to have minus ln u, and this is going to be du. No, after I integrate, this is going to be plus c, plus constant. Then all I have to do is replace the u with cos x. So this is going to be minus ln cos x plus c. Also we can write this one as, like, if you know this one, like whenever we have ln a square, we can write it as 2 ln a, both are same thing. Here we have a minus 1 in front, so I can do the repeat pattern, like reverse pattern. I can bring the minus 1 to the power, and that's gonna make it ln cos minus 1 x cos inverse x plus c. We know that cos inverse is sec, so we can say ln sec x plus c. So both are same thing, and this is not in this, and that is the answer for the first question. And usually we have to memorize these things because we need this most of the time. And let's do the second one. Second one is sec x dx. So in this one, what we do, we just multiply this one by sec x plus tan x, both side, up and down. So if I multiply sec x dx, sec x plus tan x in the upper value, and the sec x plus tan x lower. So if I multiply, what's going to happen, we will get sec x plus tan x on top. In the bottom we are going to have sec x plus tan x dx, right? Then if I multiply this one, this will become sec square x plus tan x sec x. In the bottom we are going to have the same thing, sec x plus tan x. So here, if you notice, we can take the derivative, we can take the u substitution because the derivative on top. So let's take the u, denominator is our u, so sec x plus tan x, and the derivative of this one is derivative of sec x is tan square x. No. Derivative of sec x is sec x tan x. Sec x tan x. Then derivative of tan x is sec square x. So we are going to have sec square x dx. Now I can substitute. I can write this one in terms of u. So instead of sec square x plus tan x sec x dx, I replace this one du. So this is going to be right here, and in the bottom we have u, that is sec x plus tan x. So this is 1 over u du, and this, if I integrate this one, this will become ln u plus constant. Now all I have to do is replace u with sec x plus tan x. So this is ln sec x plus tan x plus constant, and that is the final answer for this question. And let's do the next one. So we have tan cube x dx. So in this case, what we have to do, since this is an odd power, we always separate the odd power, right? So here we are going to separate this one into tan square x and tan x. So tan square x tan x dx. So there's no derivative of each other, right? So we have to change the pattern. I can replace this one by 1 minus sec square x. No, sec square x minus 1, because tan square x is equal to sec square x minus 1. So I can replace this tan square x with that one. So this is going to become sec square x minus 1 tan x dx. Now we have the derivative of derivative of tan x is sec square x. So we can take u for tan x plus u. So if you take tan x for u, the derivative is going to be sec square x. Now I can write everything in terms of u. So this is sec square x dx, but I have to separate this one into two parts before I do that, because we have minus 1 right here, so we can't directly substitute du. So let's separate this one into two parts. Sec square x tan x minus integral of tan x. So this is dx right here, tan x dx. I just multiply tan x with sec square x, and that is one function, and multiply tan x with 1, that is another one. So that's how I got this one right here. And now I can, if I apply this one for this one, I can directly find that one, right? So here we have sec square x tan x. So we know sec square x dx can be written as du. So this is du and this is u. So this will become u du, and the minus, we found out tan x dx, that is here ln sec x plus c. So whenever we have still tan x dx, we can directly put that value. We don't have to, if we memorize that one, that's why it's memorizing it easier, right? So here we are going to put ln sec x plus constant, and here it's going to be, if I integrate this one, this is going to be u square divided by 2 plus constant. Here we are going to have ln sec x plus constant. So now all I have to do is plug the u value, that is tan x. So this is going to be tan square x divided by 2 plus constant minus ln sec x plus constant, and that is the final answer. I hope you guys like this video. See you next time.